Hi everyone, and welcome to the second part of the Apollo tutorial, in which we are going to have a look at how we create the resources that Apollo uses to execute function code. And in this video, it's going to be about the resources on AWS, or more generally, serverless function on cloud providers. So this is what we're going to do in the video. We're first going to have a look at Apollo type mappings. That will be more a part where I just explain things to, put them in a context so that we have the same understanding of why Apollo requires the things we are talking about and what eventually the output of this tutorial will be. Then we will briefly look at the things you require to do this tutorial, and after that we will have a rather long practical part where I just will show you all the steps required from between where we start this tutorial and between the endpoint where you actually have those functions deployed, and actually you also have the type mappings file, which is required to provide the information about the resources to Apollo. I will briefly show you how you can test your functions. This may be interesting in general if you work with serverless functions. And after that, we will have a look at the repository we provide for this tutorial, what we kind of expect you to get as a result from this tutorial, and then just a cleanup step to remove some of the things you create during when following this walkthrough. Okay, so let's get into it. The first thing is we're going to talk about Apollo type mapping. So far, if you follow the tutorial, we've been mainly talking about the thing on the left side here, and that is the representation of the application as a workflow. So we basically said this is kind of Apollo's perspective on the application. It doesn't really care about what happens within these functions, which are these F nodes here. It instead just cares about how they are connected to each other. So it cares only about the so-called workflow, and that's what we created so far. Now, of course, if you want to run your application, you need something that actually executes this function code, and this is what we refer to as resources. So how Apollo sees that is that essentially each of these functions can be executed on a resource, for example, on your laptop or PC, or on serverless Lambda functions, and each of these possible ways of executing a function is modeled as a resource. And then Apollo sees how they are connected. It, for example, knows that your laptop can talk to serverless functions, and the other information that it requires is it needs to know which function it can execute at which resource, and that is something expressed as so-called mapping edges. For example, this first function here, which was the split function, just splitting up the string, it will be able to be executed either on your computer directly or on the appropriate serverless function. And the same applies to the shift function. It actually applies to all of them. I just illustrate this for just one of them to not clutter too much. And the same is also true for our last function, which is the assemble function. So this is just the broader context. So essentially, what we're doing here in this video, we will be looking at how you can deploy certain functions on AWS automatically in a way that Apollo can use it. And during the process, you will also create the file which you can use to provide Apollo the information, because basically, in addition to this workflow, to knowing how the functions are connected, Apollo also needs the information how it can actually execute those functions. So to summarize, the workflow, the left part, this was the topic of the previous tutorial video. At this point, we already have created a workflow file. Now, in this video, we will be looking at how to create AWS functions, how to deploy them and put them into the type mappings file. And in the next video, we will then see how to do the same thing by creating Docker images and being able to execute things on your local resource. And after that, we'll put everything together to have a running application. Okay, so that was just the context. So this is what I mean when I refer to as type mappings, and you now probably also have a better picture of what we are going to be doing in this video. The next thing, let's see what we will require for this tutorial. So there we have like two things which we will require. On the one hand, kind of the technical requirements. So what do you need to have on your system. On the one hand, you will need a Docker installation because we will be using the automated deployment we use in Apollo, and for that you need Docker. On the other hand, you will require an AWS account, and you will need the credentials of an AWS user which has programmatic access to the resources of this account, because of course we want to run serverless Lambda functions. The other things, kind of the prerequisites which you would generally require to create these functions for your application is, one thing is this workflow file. Workflow file we created in the last video. And what this basically represents is just kind of your knowledge of your application and how the functions will interact. And the other thing is you will require the raw function code. So of course, in order to implement a function which does something, you need to know how it will do that. And that's something that you can have, for example, as raw code. This is, if you look into the repository of the tutorial, which I will link in the description, for part 2, the video we are in right now, we provide something for the start. And that's on the one hand, the workflow for the Caesar Schiffer application that we are looking at. That's what we created in the last video, but we also provided as a starting point. And the other thing are basically these raw functions which we require. So that's just a file with a pretty straightforward implementation of each of our 3 functions which we need for the application in Python. And if you look at that, for example, the split function, this one just takes a string and returns us a list of characters. So this is nothing special. This has no connection to Apollo or anything like that, or to serverless functions. This is essentially literally just an implementation based on how we defined its input and output. Okay, so this is what you kind of start with. Right, okay, and with that, we are basically also already in the walkthrough part. So what we will need is we will need this function template repository. I will also link it into the description. And the first thing we do is we will just get a directory on our system and we will clone the repository there. So at this point, I've already done that. So I have it in this template video directory. And I have also added 2 more things. And that's, on the one hand, I added this Caesar file. This is the one we saw in the start right now. And this function file. This is just because it will make it more convenient to me to show you some things. And we also have this Postman request, which we will later use for testing our functions. But that's pretty much everything we did so far. So to redo these steps, just go to a directory, clone the function template repository there, and then copy the workflow file and the function file there. Okay, now we're going to use VS Code to open it up. And this is how it looks like. We're going to click away the welcome screen. And from here on out, we will basically just be following the instructions as they are presented in the repository. So what we want to do is we want to add 3 of our functions, the ones which are defined in the function py file, and we want to also deploy them then. So the portions of the README which we will need is, on the one hand, if we go to the topmost directory, on the one hand, it will be about adding our own functions. And the other thing is we will need the deployment instructions right here. But we will start by adding our own functions. So we just go there. It already assumes that we have the repository cloned. So we work with Python functions, so this is the relevant part. And for us, the interesting part will go until here, because the rest of the steps are for the deployment via Docker, for the creation of the images. That will be the next video. So okay, let's see what we do first. The first thing says, create a copy of the function template Python and name it accordingly, and that should be in the same folder. So if we go here, we see here we have the function template directory. There we have the function directory, and there we have this template Python directory. And what we will do is we will just copy it and we will create copies, and we create one copy for each of the functions which we want to create. So let's rename them directly and just call it this one split. And then we will do the same thing again, just paste, and we will rename this one to shift. And once again, and this one will be called assemble. All right, so that's that. Now with that, we don't need all the other functions here. So we can delete them just so that they don't hang around. Delete and delete. So those are the different templates for the different programming languages you may want to use. So here we are now. That was the first step. Let's see what we do next. So then we go to individual copy, and we adjust the cloud function and cloud function pi to our needs. So this is important. Now in our function, we basically have this cloud function part. And this cloud function is where we will enter the actual functionality of the code. And for that, two things are important. So we need to make sure that we have the right connection to our workflow and the right connection to our code. So what we are working on right here is the assemble function. So let's open up our workflow and let's open up our functions. We will put both of them to the right so that we can see both of it together. Now let's click this away. Now the first thing is, so you see the overall cloud function, it will be getting a JSON input and it will be returning a JSON object, because this is the connection to Apollo. Apollo will provide this function with JSON and it will expect it to give us back JSON. So now we have to see how will the object there be structured. So we are creating the assemble function. So let's just go and find the assemble function in our workflow. Here it is. So we see it has exactly one data in, and what it gets, it gets something which is called this shifted character array. So we know that our input JSON object will have this entry. So we call it like that. And the other thing we see is that what it returns will have an entry code encoded string. So this is important. This is so one thing basically means that Apollo, when triggering this function, it will take the input and it will pack it into a JSON object named shifted character array. So the function, of course, must request this value. If it requests a value with a different name, it will not work. So in this point, this is important. Your workflow file has to, so to say, agree on this with your function definition. And here then we can say that our our output will basically be encoded string, because again, this is how the output is defined in the workflow. So this means that when Apollo executes this function, at the end it will expect to get a JSON object back which has this entry. So that is that. With that, we basically have defined the function code in a way that Apollo will already understand it, that it fits the workflow. The second thing we need to do is we need, of course, to make sure that the function actually does the thing it's supposed to do. So let's look at the functions. And there we have this assemble function, which is obviously super extremely easy. So we can say that what we get here, what will be in the JSON object is actually this character list. And then this is what we want to do with it. But instead of returning it, we just want to say that, okay, hey, let's say this is our result. Our result will be the thing we get when we just take this and join it. And this result we will pack in our JSON object, which will be eventually returned. So this is pretty much it. This is the function as it needs to be defined so that the assemble functionality is carried out correctly. Okay, let's have a look at the next one. The next one will be the shift. I mean, this may be too much, but I will just do this for all three functions so that you know we on the same page as to the process of it. Again, so this is the shift. Let's see where it is in the workflow. So here is the appropriate part. Now this one has two inputs. So the first one will be this character, which will be the character we want to shift. So this is the char, and we can call it input 1 for now, and then we can say input 2 is going to be within the same JSON input, a different under a different key, and the key will be offset. So you know, we have multiple data ins, and that means that Apollo will take these different data and pack them into the same JSON object with these keys, and your function has to unpack the JSON object following the same logic. This is important. And the other thing is, just as before, we need to see what are the outputs, how will the output be provided, and we need to use the same key here because this is what Apollo will expect from the function. All right, so that's so far that's again the part that we need to make it fit the workflow. Now let's go to the functions. Let's see what the shift function does. So it gets this original character and the offset. This is nice, and we can just rename the things accordingly. Character, and the second thing will be the offset. With the rest, we can just take all of this and copy it over here. And at this point, we actually will already have the result. So the only thing we need to do is we need to say at the end that we return the shifted character as the result. And that is once again it. Okay. Last time, again, I mean, you know, honestly, feel free to fast forward it if you don't want to see it like a third time, but I just want to make sure that this is understood. Last thing we need to do is we need to look at the split. Again, we look, where is it in our workflow? That's the split function. What does it take? Well, it takes one thing, which is called original. So we go here and say that original is what we're going to get. And it's going to have an output, which is going to be basically called character array. So let's say this is character array. This is the part which we need to do with the workflow. And then if you look at the part with the split, this is extremely simple. Once again, this will be called original. And then the processing will be just that result is list of original. And we will return the result. And that is completely it. So this basically, with that, we are done with the first part where we have adjusted all the functions following the code that we had. So we had raw code, which just said how what is the function supposed to do, and we had the workflow, which basically described how what expectations will Apollo have towards this function regarding its input and output, and we adjusted this cloud function, which is essentially the interface between Apollo and the function. Okay, this is nice. With that, we can close these two, and we can proceed to the next step of the tutorial. So this is what we did. We adjusted the cloud function copy to our needs. Now follow the layer guides, AWS and IBM. This is in case that your function has some library requirements. We won't be looking at that. Instead, we now want to actually deploy the function using the guides for AWS and IBM. We are working with AWS, so let's go there. Now, the first thing is we don't care about Node because we are in Python. So let's scroll down. Okay, so here we are. First thing we need to adjust is this AWS deploy sh. So let's have a look at that. This is not here. We are from now on in this AWS directory. So let's go to deploy sh. And here we are. Now, let's see. First thing says that we need to adjust before Terraform init. We have this functions, your function name, where we will input our functions. So let's go all the way down to init. So you see that as an example, we have this template Python and template node. This is what we had before. Now we have these other functions. We have assemble, shift, and split. So let's just enter this there. And split. Okay, that's the first step. Then the second step is, this is nearly all here. Now, there is also one other thing that you need to do in this first line here, when we have the show URL, this number here, it has to correspond to the number of functions you are deploying. In our case, it's fine. It's 3, so we let it like this. But if you would deploy more or less function, you would have to adjust the number accordingly. Now, the next thing we do will be in the lambda.tf file. So there, let's see what we have to do. Basically, that's a pretty systematic thing, what we are going to be doing here. And actually, it could be automated further. I'm not sure whether we're going to keep it like that, but for this video, I would just like to show you what to do in the way it's implemented right now. And what you see here is we basically have several arrays which just define things. So we have the function names, and then that's the first thing is the function name. Second thing basically tells us where will it be able to find the zipped contents of each functions, which runtime do they use, which handlers do they use, which layers do they use. So what we need to do here is we need to say, again, this is by default it's created with these two examples in mind. We again will redefine it following the new functions we now have. And the important thing is that from here on out, kind of the order matters in which we define that. It's not as bad here because, for example, they will all have the same. Runtimes, but nevertheless, what I mean is that in each of these arrays, for example, the first entry corresponds to a sample, so you should keep it like that. You shouldn't switch the order at some point. Okay, and the last thing we need is the split. At this point, okay, now all of them will be Python, so we can delete the Node.js and just copy this 2 more times because we have 3 functions all run in Python. And they will all use the Lambda handler, which is expected by by Python function. So you can just copy this value, which was here for the template Python. Okay, and all of them will not have any additional layers, so we have 3 empty entries for the last part. Okay, so that was essentially, we added the function name to the function names array, we added the path, we added the runtime for each of them, we added the Lambda handler, and we added the appropriate layers. Here you have an example how it looks. This looks similar to what we had. Now, this is the next important thing. We need to add the AWS API Gateway. So why we're doing that is we will be using Terraform to do the deployment for us. And if you're familiar with serverless functions, you know that you need 2 things. You need on the one hand to deploy the function itself, but on the other hand, you also need to deploy an API Gateway, which basically will make this function accessible from the outside, because Apollo will use that to trigger the function execution there. And this is what we need to do with this block. So let's have a look at that. So we are looking for the entry AWS API Gateway deployment. Okay, so for that we need to scroll all the way down to creation, and here we have deployment. And here you basically see this is defined based on entries in the array. We now have an array with 3 functions. So what we need to add is we need to add an additional one for our third function. And it will be example 2. And then we need to adjust these entries where we actually look into one of the entries of our arrays defined up there. Okay, and that is that. This was this step. And finally, we need a new output block. This is not extremely important. This is just, so that the output that we display at the end with the URLs matches to the functions. So let's go do that. And there again, the important thing is that it actually corresponds to the order we chose. So here we can say assemble is first, or like it should be URL assemble, and then URL shift, and then similar third time URL split. And this will be example 2, walk URL. Okay, and that should be essentially all we need to do in the lambda.tf file. So this is the what we need to adjust with direction to the auto deployment script. And from here on out, we can actually have a look at how we would actually deploy it. For that, we go back to the function template and look at the actual instructions for the deployment. Now, the first important thing is we need to save the credentials to our cloud provider in the according subfolder. So for that, you need an AWS account. I won't go over it right now, how you do that. I will include a link to how to do that in the description. And there you will need to get your credentials file, which will be looking something like that, with like some entry here and some entry there. I won't be showing you the step how you define the credentials, because you also should be very careful to never show these credentials and also to never upload them anywhere, because that could cost a lot of money. So what you need to do in this step is make sure you have a created account, get this credentials files. For example, if you're using the AWS CLI, then you will already have this credentials file on your system, and you just need to copy this default entry and to put it into the credentials file of the AWS folder. So I would just assume that you did that. And the next step will be basically down here, and we will be deploying on a single provider with custom settings. Now, for that, in this tutorial, I will be actually using a different directory than the one we just worked in, just because, you have a lot of copy pasting and typing there. It's super easy to make a mistake. So I just want to have something that actually works out for sure, not to redo this video. I will include a full directory of this auto deploy in the result section of the demo, so that you can see how it looks when it's configured properly. It should be all the steps, but it's just possible that I make a mistake somewhere, and I want to show something that works for sure. So this is essentially same thing. Function template is just something that I tested before that the deployment actually works. Now, one thing that we're going to test before actually trying it is, as I said, you need a working Docker installation. So you can check that by checking Docker version. And if it shows you something, it basically means, okay, you have Docker installed, everything works fine. And what we then need to do is we need to go to function template AWS. This is where we start off. And then we will run this command, which you can just copy paste. Now, the important thing, now what will happen here is this one will download an image which Chris and Jakob created, which contains all the Terraform dependencies which you need to automatically deploy that, and then it will do the deployment using the scripts and the function files you defined in that directory. So let's just do that. Let's copy, paste it, and just one thing to mention, which I require on my system. We also need to say network is host at this point. I'm not sure whether this is universally required. I have this relatively weird setup where I have a Windows system where I use a Linux virtual machine, and that's super confusing for Docker containers which need to access the network, as in this case. So with this, it works more reliably. Should it not work, should you get an error where it says that it can't get some packages. Honestly, just restarting your system sometimes solves it. Maybe you also need to add this network host parameter to this command. But now let's execute it. So what happens here is exactly the thing that will happen at your system, where it says that, hey, it needs this image of Apollo auto deploy, and it doesn't have it locally. So then it will download it. Now, I can tell you right away, this step will take a while because the image is, I think, around 2.5 gigabytes large. So this will take quite some time. I also won't keep all the waiting time in the video. I will jump ahead in just a moment. So don't be like surprised. It will take a while, and we also have this cleanup step at the end of the tutorial because there we will remove this image again, just so that you don't have this 2.5 gigabyte image hanging around there. Okay. Yeah, so at this point, we will then have like the small jump to the future, just to the point where the image has finished downloading. Okay, so at this point, we basically downloaded the whole thing, and now it actually starts. So here you see that it works. This is, by the way, exactly the point where it may not work. It may at this point say that it's not capable of getting some of the packages it needs. If that happens, either restart your system and try again. This may solve it. Or what you can also do is you can just kill the container and literally run the same command again. So at my system, these are kind of the workarounds to solve that. Also, one thing to mention, if you look exactly at this text, you will see that in my case, it basically says that it refreshes and modifies the state of these resources. It will say something different. In your case, this is the reason for that is that with me, the functions are already deployed once. With you, it will deploy them for the first time, but it doesn't really matter. You shouldn't really care about what it says. Now, the important thing is, at the end, it says, okay, hey, nice, apply is complete. In your case, it will have added 3 resources. In my case, it says change because they were there. And then it provides you these URLs. And these URLs basically are the URLs under which the functions are now available and reachable in at AWS. So if you send the input there, you will receive this output. Now, the second thing we do is we do again the same command, but we now say mappings at the end. It will again output us the URLs. And we did that because what it does for us with this, it is creates this type mappings file. And this type mappings file is the file required by Apollo. So to Apollo, you would provide the information about the available resources using this file. And you basically see that it says, okay, so for the function type assemble, you have different resources, in this case, one. The type of it, it's serverless, and this is the URI under which you could reach it. Same thing for shift, same thing for split. We will see later on in the video where we assemble everything we created in the tutorial, how we use it to provide information to Apollo. But essentially, this is just for Apollo to know that if something, if a function in a workflow says that it has a type shift, for example, then this serverless resource is one of the resources it can use to run that. Okay. So with that, we are basically through the type of the through the part of the walkthrough where we use a deployment script and generate the type mappings file. Now I will just quickly show you how you can test that your function is actually deployed correctly. And for that, we will be using Postman. So this is in general a super cool program. If you're working with serverless functions, I would definitely recommend you to use it. So you can do what we are about to do, that is just check out whether it's reachable, whether it gives you the output you expect, but you can also really create tests with that, which are run as unit tests to make sure that everything is working correctly. And for this tutorial, we already provide you with what is called a Postman collection. And a Postman collection is essentially a set of requests. So when on your system you have installed Postman and you open it, then it will, after some loading, as you see, show you that you don't have any collections. And then you can import it. And wherever you download it, this Postman requests file that we provide in the result section of the tutorial, you can just load it into Postman. and then we hit import. And you see we have these tests here, and each test tests a certain of our functions. So we have this request shift, for example. You see it addresses a URL, and as a body, it has this JSON, which says I'm sending the character A, and I have an offset of, say, 2. An example, then if we hit send, then you see that what comes back is C. So A shifted by 2 gives us C. If we, for example, go with a small d and shift it by 1, or like say -1, then it basically will give us a small c back. And that's exactly what we wanted. If we look at assemble, again, the body says we are sending the Apollo string, the characters of the word Apollo, and what comes back is the full word, and the split does basically the opposite. And this is actually, this is run against real functions, against the functions that I have deployed there. Now, one important thing, when you use the collection, this won't work initially in your case because your functions will have different URLs. So what you need to do is you need to go here and click edit, and there you can go to variables, and there we have these 3 variables defining our URLs of the functions, and there you need to add your the appropriate function URLs there. Okay, yeah, so that's that part. Just to show you again, so in this video you see that you actually have these links here. Now, just as an advice, you should actually never be doing what I'm doing here and showing someone the URLs. At least the way we deploy it in Apollo, they are reachable for anyone who knows the link, and I will actually remove them from my AWS account after this video, so you won't be able to execute them. But as soon as you have deployed your functions, be cautious about the link, because someone running requests against it will basically be doing that using your money. Okay, so that was basically that thing. And the very last thing is we will have a look at the result. So what do we provide as a result in this part of the tutorial? And if you look here, we have 2 things. On the one hand, we have the type mappings file, where you can check that the type mappings file you generated looks correctly, looks the way that it should. You have these Postman requests, which you can use to actually check that your deployed functions work correctly. And we have this deployment directory, which essentially is exactly the deployment directory I just used to deploy these functions. So the way this is configured is kind of the correct way. And again, just to remind you, if you ever upload credentials, make sure that you don't have anything. So this is in general something to be cautious about. It's very convenient to use something like this deployment directory in connection with version control, because you want to make sure that that the stuff is working and that you have a version history, but make sure that you don't upload your credentials. Okay. With that, we are nearly done. I will show you one last thing, and that's how you kind of clean up after the system. So I think that this image for automatic deployment is really cool, but the big downside of it is it takes 2.5 GB of your space. So what you can do afterwards, when you are through with everything, you can just go ahead and say, okay, let's see whether something is running. So nothing is running right now. So what we can do is we can say system prune and prune everything. It will ask us whether we actually want to do that. We hit yes, then it takes a while, and then it basically says that it reclaimed these 2.5 GB of space, which you probably want to do if you don't execute this deployment script very frequently. Okay, with that, we're through. I hope it worked out. At this point, we actually could already run the application with AWS resources only. We won't do that yet. In the next video, we will have a look at how we deploy your function code as a Docker image, so that you can also run it locally on your machine. And after that, we're going to have a video on assembling everything and having a running application. Hope it was interesting. Hope to see you in the next video. Bye.